For my part, I'm Michelle Avomo. I'm full stack developer here in Paris and co-organizer of the craft community at SOAT, which is a consultancy company based here in Paris. And I'm also it's important to say that I'm co-organizer of the craft community because, at some point that role led me to this kind of routine where we plan with my teammate. We will plan what we want people to grasp as main concept in the craft thing, and then we will learn and practice like everybody, like every time, and then we will have the teaching part. As you know, teaching is learning twice, and it forced me to kind of structure everything that I know about one concept, and actually to try to find the easiest way to share it to people so they will come and they will really find value in what we are sharing. And for some reason, well, we have been doing that for a little while when we reached the solid principles. And solid principles, having to teach them, to me, felt a little bit like this, because it's not because they are exceptionally hard. It's mostly because it's easy to, misunderstand them. And when you have to teach something, you are really scared about the fact that maybe you are saying mistakes, and people will just start thinking, "Oh my God, why am I going to that craft community?" This is one reason. The second reason, it's also because in our community, what we choose to do, it's like, okay, instead of just reading a definition of a principle and just say, okay, we got it, and we see an example, and that it's like you can go home. We actually live code an example and just give an exercise. And giving an exercise, it's a very complicated. Finding an example, it's okay. An exercise should be not too simple and not too easy. It should be not too hard, so people will just, they will see how they are grasping ideas. And live coding is just a way to tell them, look, it's possible to go there. And the thing with the dependency inversion principle is that I couldn't find a kata, an exercise that is not too simple and not too difficult. I need to give people like 25 minutes an exercise so they can just understanding by doing that. That's why I kind of, simplify. I kind of made one for me and my teammate, and I'm happy that I have some people who can be interested in that. So if you never encountered a dependency inversion principle, or if it's been a long time that you read it, just remind you the main definition. It's like high-level module. It's on 2 points. High-level module should not depend on low-level modules. Both should depend on abstractions. Abstractions should not depend on details. Details should depend on abstractions. This is the formal definition that you will find for dependency inversion principle. And my task as a organizer of the craft community is try to take this simple definition and make it simple to implement in a day-to-day life. And how can we do that when you see that you have the notion of high-level module, low-level modules, and you have those kind of details everywhere? And what is a high-level module? What is a low-level module? What are the details? And why do they insist in those abstractions? What is the main point of dependency inversion anyway? Why do you use it? And have you ever encountered it? Well, this is actually all the questions that I have to answer in 15 minutes. So this quick kata, it's actually it's not all mine. I took it from Matteo Vaccari, who made an hexagonal architectural kata, and I simplified it in order to just make it more, funny. So instead of an employee sending greetings to his employees, it will be a user who sends some greeting emails to his friends on their birthday. And then going from there, I'm just moving to the code. So you will see how it looks like. Up here. I'll just move to the presentation mode. Hopefully, everything's good. Perfect. So we have this kata that has, okay, project. Sorry, we did 2 or 3 things. So the kata is quite simple. It's a kata, right? You have one main class, which is birthday greeter, which has 2 main dependencies. The friend repository dependency, which has no implementation. We don't need it for this exercise. And we have the new email. We have the email sender, which is actually the way we are, as a company, we are sending the greetings. And I oversimplify it because we actually don't need a proper email server or whatever. We just need, to be able to say, okay, whenever I write something in the console, I send an email. So the integration tests are just to say that if I never find a friend born today, I will never print anything in the console, so no mail. And if I find a friend born today, then I actually print something. It's important to show you, so maybe one day you will like it and you will want to replay it. So that's it. That's all my code base. Birthday greeter, friend repository, and new email sender. So what's the matter? So far everything is good, right? The thing is, we've been doing that. We are a company, we've been sending emails for all the birthday. People have been sending emails. And then someday some product owner comes and they say, well, we don't want to do any email anymore. Finish. It's 2019, now we are doing SMS, we are doing text messages. Okay, that's good. So you go back to your code and you say, at some point, where we are doing very long sprint in this talk, you see, at some point you just say, saying that we are no longer using email sender means that this email sender can disappear for some reason. And what are we saying? What we see is that deleting email sender or moving it to another place makes that the birthday greeter doesn't compile anymore. If you can kind of imagine that in a big code base, that means that you can ship code to production. That means that an entire team can be blocked at some level because of, you have a very coupled dependency between the idea that you want to send the greetings and the way you are sending it. So after a while, you can say, okay, this is not a big problem, as we really want to remove the email sender, and sometimes we want just to focus on the SMS. But until you figure out how to write the SMS sender, this birthday greeter doesn't work anymore. So your application is like, I don't know, no, you can't just ship it. Nobody can work on it. You're waiting for the other team to finish. And this is one of the main problems when you have that high coupling in the code. And the whole point of dependency inversion, what it can bring to you, it's a flexibility, and it can bring you some flexibility so that you never have to wait for like another team to finish in order for you to start in your development or even change your mind. So this is where it gets interesting. I don't want my birthday greeter ever to stop compiling when I'm writing my code, because this is not the way it should work. What I really want is the ability to just say, okay, if I detect what is my high-level module and I know what is my detail, then I can just, take the detail, give it to one team, and the high level, give it to another team, or just have my tests which are validating that what I'm doing is right. So it starts with defining what is high level and what is low level. And don't forget your abstraction. Okay? So that's simple. You map the idea with the implementation. So what is our detail? What is our low level? It's the way that we are sending the greetings. So it's the email that we are sending. I want to be able to say, okay, tomorrow I get rid of the email and my birthday greeter is still working. This is just a way for you to just take it. Maybe you already know that, maybe you like it, and maybe it would just make sense for somebody else. And you say, okay, what is the main feature? The main feature is my birthday greeter, which should always be looking for friends born today and sending them emails. That's the thing. This is the first step. The first step is finding what is the high level, what is the low level, and now it shouldn't compile because this is not public. Perfect. First part, kind of done, but not that easily. Because so far, what I only did, it's just to move the low level so that you can just say, when you read this sentence, high level module should not depend on low level module, then it's obvious that your high level module, your low level module, it's really like, if you delete it, your high level module, it's depending deeply on it. So this is, it is depending on it, so it shouldn't compile. Yeah, so it's red. It's like TDD, but with packages. And what is going on? What is going on is that I really want to introduce the new way of sending greetings. So I would just, TDD the thing, and I would just go here and say, okay, so far I've been sending email. I don't want to send email anymore, but I can't delete the test until I have my SMS done. So what I really wanted to say that here what I really want is the ability to say here I will always let my client or my user defining the kind of the detail to carry the greetings that I want. This is the idea, but I can't do that now. So I will just make this not passing. It will just be like a pending test until I show you something. Okay, that's it. So you see, this code doesn't work. This code doesn't compile, and it doesn't compile just because I decided that here. You see, the main problem with this code is that my dependency is hidden in my code base. So I can't actually control from outside what I want to inject, dependency injection. What I really want is to have a SIM, and the SIM will allow me to just say, okay, every kind of application can call my API and just give me the detail on which I should just carry the message. This is the main idea. I just wanted to have a SIM. And here I can just go a little bit further, just be a little bit faster because of the time is running. And I would just say, okay, I actually extract a message, an interface, an abstraction, the abstraction, and I say, okay, this abstraction would just be this way, up. And having an abstraction would just make me say that I will just come here and I will say that this here, it's like, this will depend on abstraction, the same abstraction than this will depend on the same expression than the email sender, and I will just copy and paste the message because I don't have the time to do it in a finer way. Okay, this is done. This is kind of good. It should work. It works. So this is the thing. I extract you see, we said low-level module should depend on abstractions, and if we see well, you have the email and the SMS that depends on the messenger. But there is something that is wrong, is that this messenger, it's in the low-level module, and we already saw that every time that we delete the all-level module, the birthday greeter doesn't work anymore. So it's not just a matter of having an abstraction somewhere. It's a matter of where do you put your abstraction. You put your abstraction away from your details, because what you want your details to do is to implement the contract defined by your high-level module. That is the one little subtle thing that is a little bit difficult with dependency inversion principle, is to understand that your messenger here, well, you can actually move your low-level module, and it's just a detail. You can change the timeline on which you develop your high level and the timing that you develop your detail. You don't have to couple them. And the thing is, I just moved this abstraction. I put it here right away, but actually the idea is to say you have the abstraction package that was empty as well. If you put it out of your high level module, your service manager, your API, then your high level module is not complete. Your high level module should hold with it like a component the contract that makes it works, like independently as a module. So that's why the abstraction should always be inside the high-level module, so that you can take it from this birthday greeter and send it to another module in your company or outside of it. And this is more or less the whole thing about dependency inversion principle. If you never actually encountered that, I hope like you see the idea. But it really helps you not only in the test but also in your day-to-day life, because one of the hardest problems that we can have in writing maintainable code and flexible code is the ability to change your mind. Change being the only constant. You want to be able to say, okay, let's see if I don't use a database and just try with some hard code messages. And we can go any further. We can go further because we can say, okay, this kata, if you ever run it, has more than one responsibility, because it actually, if you see here, the fact that you see what I did earlier, I just copy and paste whatever I had in my email. And when you send an SMS, you don't need an email address and you don't need a subject. You just need your text and your phone number. That's it. So you can go from this dependency inversion to start having some design smell that lead you to like a single responsibility principle, respecting OCP maybe, because you have to choose the right abstraction, maybe, if you can find it, and so on and so on. So this is my key take. It's just, little trick for explaining dependency inversion principle. Thank you. If you have any question. Yeah. Yes.
It was also, thank you. Thank you, Michel, for your talk. It was also some introduction to OCP, open close principle.
It can be, but the problem with the open close principle is that you really need to know what is the main abstraction that you are looking for. We could have started and say, okay, we actually don't want to change the way we send the messages. We want to change who we send the messages. Then the problem will be totally different. We will also have this high level, low level. And this kata, you're not obliged to take mine, you see. The fact that you kind of check, reveal what is your high level module and what is your low level module depends on your domain. This is just a way for me to just say, if you ever need it someday, you can go grab it, and you have very few dependencies, and you can give it to anybody for like 10 minutes, 20 minutes if they are slow, and they will just get it by doing that.
Do you have katas for the other solid principles, and are they published somewhere?
We have them in on our GitLab, and but I don't have them in my personal GitHub. So for the moment, I can actually share them because we have those for interface segregation, single responsibility. This one you can use it for single responsibility, even though you already have very good kata that exists for that. And you also have the OCP. We use the Martian kata, the Martian boolean. I don't know if you know. Well, I can just give you some, and that will be, good. Thank you very much. Have a nice end of the talk.